like in contrast to involved in the functional programming world for a tiresomely long period of time at this point. I have been working at Jane Street. I'll speak a little louder. Sorry.
Should you use a microphone?
This. Excellent. How's that?
Yeah.
All right. Okay, so I've been doing functional programming for a long time, and in particular, Jane Street has been a company that is really unusual in the way that it's taken functional programming. That we have really jumped in with both arms and both legs, and there's no extracting this from this point. And unlike other places where you really see functional programming have a deep hold, we are a company that is not really tied to the kind of historical places where functional programming has been its strongest. If you look at the kind of places where you see functional programming having a serious hold, like a great example is Galois. Right? So Galois is a company which is all about formal methods. And really the history of functional programming is deeply enmeshed with the academic fields that's hooked into. And so there's a lot of there's sort of clear connection there, and you can understand how historically that all got hooked up. And we're a much weirder story. Jane Street is a proprietary trading company. So, and we have come to use functional programming pervasively everywhere in everything that we do. And I think this kind of unusual nature of the commitment that we have to functional programming and the nature of the business makes it an interesting case study. So I've talked about Jane Street and what we have done a while ago at CUFP, I think 2006. And what I'd like to do now is kind of update that picture and say where we are now. It's been more than a decade that we've been using functional programming, and I kind of want to give a sense of how that can proceed and where they can take you. So I am going to fail to make my slides work. There we go. So before talking too much about the technical side, I want to give some sense of the business, and I'll do this very briefly. So Jane Street, as I said, it's really not working so well. So Jane Street is a proprietary trading firm. So that's a somewhat obscure piece of jargon. But what it roughly means is that we are a company that makes its money by trading on the open markets. We don't have investors. We make our money by providing services essential to those that we interact with. So depending on how you answer the question, who are our customers? On some sense, we don't have customers. There's no one who knows us as a service provider. But on the other hand, a large fraction of the people in this room are probably our customers. Every time someone goes off and makes an investment in the open markets, companies like Jane Street are on the other side providing liquidity, and meaning that when you go to buy something, you get a slightly better price, and when you go to sell something, you make a little bit more money than you would otherwise. So it's a business that involves interacting with lots of people anonymously. So one of the things that means is you get to do interesting and technical work, but you don't have to wear a suit, because there's no one who knows you as their provider. You're interacting through anonymously. So actually, I think this is the first time I've worn a jacket in about 6 months. I dress much worse than this at work. The company also has moderate scale, right? We are not an enormous company. I always think of us as perched kind of right between small and big, right? We have about 320 employees. They're spread across 3 continents. We have offices in New York, London, and Hong Kong, and that reflects the global reach of the trading that we do. We trade in dozens of markets and lots of different classes of securities, and billions of dollars flow through our systems every day. And to be like, more nominal value flows through our systems than we have, right? So there's another thing to understand about this business is there's a certain amount of existential terror that one should feel doing this business. If you make a stupid mistake, you can go out of business right quick. So that has a lot to do with the kind of technological decisions that we've made. It's also really complicated. It's complicated in a number of ways. Like you have to build systems where your own strategies and your own ideas that you're trying to exercise in the market are complicated. But there's also an enormous amount of exogenous complexity. Things coming in from the outside that make your world harder. Whether it be strange regulatory regimes or new classes of securities or bizarre venues that you need to trade on or some very strange new kind of security that settles in a bizarre way. Like, there's a lot of complexity, we do lots of different things, we have to have lots of systems that interact with it. And this is a big challenge, right? The combination of lots of complexity and don't screw it up. Right? Those are hard things to do at the same time. And in fact, it's actually a third thing that we need, right? We have lots of complexity, we need to not screw it up, and it all needs to be pretty fast. Right? I think that interacting on the markets requires and rewards good performance. And so, you know, the sort of thing of the triad of things we need to get right. We need correctness. And that one has to come first, right? It's not an accident that's the first one, right? Because, you know, we are not trading investors' money, we are trading our money. And when we light ourselves on fire, no soul will bail us out, right? We are just going to die. So the only thing we really worry about our own capital and making sure that we don't lose. And so correctness is an extremely high concern because, as I said, it's a dangerous business. Agility is also important. You need to be able to change things quickly. You need to be able to come up with new systems and adapt to new circumstances because that's where the opportunities are. And performance, as I said, matters as well. So those are kind of all kind of background issues to this business that we're in, to this enterprise that we're engaging in. So the next thing I want to do is I want to kind of start trying to walk you through some sense of what we're actually doing on the technology. What are the different application areas? What are the kind of systems that we build? Because I think the thing that seems to me most notable about what's changed since the last time I spoke publicly about James Street and how it works and today is just the kind of technological depth, the number of different things that we have done, that we have built. And one of the reasons why there's such a variety here is because we've really applied functional programming ideas and we've really applied our kind of own software methodology approaches to like all of the different things in the life cycle of the company. It's not like we go off and build trading systems. We build all sorts of things. So let me talk a little bit about some of those application areas. So one area which is very close to my heart is where I started working at James Street is on research tools. And part of what we do, a big part of what we do, is doing kind of statistically guided research into trading strategies. The work that we do is very quantitatively oriented. And when I started, when I first came to James Street and imagined that I was taking a small leave from academia before I went back to be a professor, I was working on some research tools, and I sort of imagined that it was all throwaway code, as research code normally is. If you look back at some of that research code, it should be thrown away. But in the end, what really happened after 6 months and 80,000 lines of code, I discovered that infrastructure was going to live on. And the offhand decision I had made to write it in OCaml turned out to be fairly faithful because I didn't want to rewrite it into something else when it turned out I was staying. And so that was the beginning of us hiring other people than me to work on functional programming. So the next area where we stepped into was actually the actual trading systems. After a few years of me being there, we realized that we needed to redo our software technology. In fact, we really realized from the first day that we needed to redo it because our original technology stack was based on Visual Basic being written in the back of an Excel spreadsheet. Our automated trading systems were written that way. And it's a little less crazy than it sounds. In that even then, that Visual Basic code was taken extremely seriously. Like, people who had founded the company, the most senior people, actually read over every line of code that went into those systems. And in fact, as code goes, it was pretty straight ahead. It was pretty concise. It was possible for humans to understand. But nobody imagined that was the way forward. Right? It was clear that we needed to redo things. And after the positive experience we had with the research tools, we decided that trying to use the same functional programming techniques on the trading systems was a good idea. And that worked well, and indeed, our entire trading infrastructure has been flipped over to programs in OCaml, and that happened a long time ago. The next thing that we pulled in was order gateways. This is another important part of the infrastructure. This is basically the part that connects you to the exchange or the broker or whatever other kind of market you are connecting to. And it's also a piece of infrastructure that is super complicated, and it's very important to get right. The re-implementing these was a big win and greatly improved performance and greatly improved the correctness of the systems and allowed us to get much more control over what we were doing than we had before. But I think one thing to say about this is, this really taught me what a hard slog it can be to replace legacy software. Because, you know, the people who had worked on the order gateways that had come before had done quite a bit of work and quite a bit of good work, adapting to lots of different markets. And functional programming is no doubt a great help, but it is not a panacea. There's still the inherent complexity of every new thing, every new connection you have to build, you have to learn all the horrible details of how this guy's protocol works. And you have to then relearn it again when you discover that the specification was a lie, and you have to test, and you have to think about all sorts of horrible corner cases, and think about the terrible gap between the specification and the world. Right? So, you know, even if you have the right spec, the way that things go wrong, the kind of bugs that people have requires very careful kind of defensive thinking. And even with the help of functional programming, even with these great programming languages, it was hard work, and it took much, much longer than I expected it to. So another huge part of our world is what we call post-trade. Right? There's all, like, you have some system, it gets in market data, it makes a decision, it sends an order, it gets in execution, and then, you know, maybe you think, oh, now we're done. Like, we either made money or lost money, but no, it turns out there's an enormously complicated stack of systems after that need to pick up that trade and distribute information about it to people internally, and then understand the implications of that trade for the operations part of the work of dealing with the clearing firms and other outside entities that you have to deal with. And in part because of the complexity of the things that we trade in the markets that we're involved in, this kind of post-trade infrastructure, which is in many companies given the ignominious name of the back office work, is actually super important and really essential to what we do. And it also, much like the order gateways, involves, you know, embracing terrible structures of the outside world, and it's a lot of hard work. But nonetheless, you know, the application of, you know, extremely smart programmers and good functional programming techniques has gone to very good effect there. Another thing that we do in OCaml, which is not enormously common, is we do systems administration. We have this living, breathing, terrifying, live infrastructure that we trade through every day. And I think having good tools for managing that has also been an important part of the work that we do. Another thing, development tools. Development tools have become a bigger and bigger part of what we do. It's not like it's, you know, 50% or 20% of the developer effort that we spend, but we really put much more thinking into developing our own infrastructure. We have 80 people who are full-time developers, maybe 100 to 120 people who you know, program some of their time in OCaml. I think Mark Shinwell took a look at, who works at JStreet, took a look at our OCaml users list and clocked it somewhere around 100, and that's probably a little bit of an underestimate of the people who are really using the language. So syncing time into development tools starts to matter a lot, and it actually shows an area in which functional programming languages kind of suffer the normal fate of a minority language. Right? The languages themselves are shockingly and miraculously good, but the tools you can't say the same for. Right? And we've had to build a lot internally. One of the areas that we hope to work with other people on is really improving that part of the world. Another area that we've done more work is trading tools, like the interfaces that you give to the traders. It turns out we don't just have programmers and computers, we also have traders, people who make kind of detailed decisions about sort of monitoring systems and thinking about the trading that's happening, and thinking about the game playing aspects and the quantitative aspects, and looking for new opportunities. And those people need tools and need user interfaces that they can use for seeing what's going on. And we've also built those in OCaml. And that's in some sense been a challenge. And I don't know whether to be proud or embarrassed of the kind of solutions that we've picked. The user interfaces that we write are largely written in cursives. For those of you who are not old like me, cursive is an exciting 1980s technology for doing terminal-based applications. What's that? No, I think cursive was the 80s, actually. Because cursive was like the second wave. I thought it was the 70s too, but I went back and looked. And cursive was the second wave of like, you know what, this terminal is too hard dealing with our BT100s and our DEC X and whatever. You know, we'll have a nice abstraction layer, and then we'll build, it's actually a terrible abstraction. But anyway, the cursive thing is neither here nor there. The real point is we build these text-based user interfaces, and they are the most sophisticated, colorful, detailed, information-dense text interfaces you have ever seen. And on some level, I think focusing on text has been a very good decision for us. I think it turns out that people who are doing the trading work really care more than anything else about information density and speed. Right? They want to be able to quickly navigate, and they're very good with keyboard-based interfaces, and Cursive is very good at providing that. And on the programmer side, the advantages of this kind of approach is, one is it stops you from wasting your time doing a bad job of user interface design, right? It's sort of, you can't adjust like how thin that bar is. You can't make the font size a little bigger. Like all you can do is arrange the data in a dense and clear display and maybe pick some colors. And when you have a bunch of people who are incompetent user interface design, not letting them do it has some value. and in addition, the programming model that you get in this kind of text, it's very easy to reason about the performance. You don't have a lot of stuff you don't understand going on underneath. And so that also helps in building good applications. But it should not be forgotten that part of the reason for this is OCaml is terrible at the graphical user interfaces. Right? There aren't really great libraries for it, and the infrastructure there is just not very well developed. So while at some level I'm proud of it, I should really also recognize the feel of embarrassment as well. Market data, another huge part of the world. There's all these different exchanges, you need to pull data from them, and there's a big data problem of getting that data and storing that data and delivering it to lots of people and dealing with various and sundry errors that occur. So that's another big part of the world where we used to mostly buy third-party software for that, and we still do a fair amount of that, but we also build more of that stuff internally. And then, I guess finally, and perhaps the one that I think is most interesting in some ways, is we've embarked on what I'll call desk infrastructure. And what I mean there is the trading desks build their own software infrastructure, have always built their own software infrastructure. It used to be in Excel and VBA, and increasingly it has been in OCaml. And one of the experiences we've started to have, we started this last year, and now, in fact, about to start this again, is every incoming trader goes to an OCaml bootcamp, where they study functional programming. They learn, not just functional programming, they learn OCaml, but they also learn the Unix shell and how to use Emacs and how to use a variety of tools that are kind of part of our tool chain. For about a month, kind of taken away from their ordinary training on the trading side, just to learn the technology side. And that's because it has become clear to the company, sort of apparent to people, that there's just an enormous amount of value of hooking into this infrastructure that we've built. And I think one of the things that we've seen more and more is as our infrastructure improves, the value to us of that infrastructure grows, and people more and more want to hook into it. And it's become less and less as time goes on. A small group doing this functional programming and for the firm's infrastructure to something that's really pervasive throughout the company. Let me just say a couple of words, because I'm clearly running short on time, about kind of what this platform is that we built and what are the important pieces of it. So one thing that we had to build, and this is sort of the standard joke about OCaml, which is if you want to use OCaml, the first thing that you need to do is you need to write your own standard library. And that's because the standard library that comes with the compiler is in some sense better thought of as the library that's used for bootstrapping the compiler. Right? The core team is more focused on building the great compiler that they built, and less focused on building a whizzy standard library that has all the things that you need. And so that's something we built for our own, and in fact released publicly, and something that people on the outside can use. Another very important infrastructure is async, and along the lines of the previous one, async is a library for concurrent programming, and it provides a different set of abstractions than you get in your normal, ordinary functional programming within OCaml. And I guess one thing I'll say is there was a comment earlier about this idea of, well, functional programmers get nervous when they see different abstractions at one level than they do at the next. And I actually think this is in some sense a mistake. You should have different abstractions at different levels. You still want ways of recombining things, and you want, you don't want to have breaks for no reason. But I think much ill has been done in the world by saying we need to take the complexities of the big world and bring them all the way down, right? Everything's like a concurrent thing sending messages to each other. And that's hard to think about. So let's make everything hard to think about. Right? No. Right? And if you want to take the things that are easy to think about them and push them as far as you can, and only get into these other modes of reasoning, these other difficult approaches when you need to. And async is a library that's designed to make explicit in the type system where you're doing this kind of concurrent programming and where you're doing the kind of simpler synchronous programming that fits more easily in our small human brains. Another example of a system that we've built is another kind of monadic library system, other kinds of ways in which you can kind of push the system for doing large-scale computations which can kind of be incrementally updated and recomputed and just recompute the part that's changed. This is similar in spirit to the work that Umar Sakar and various other people did some years back in self-adjusting computations. But just another example of kind of a core piece of infrastructure that really leverages nice ideas from sort of the nice structures of the type system. I'll mention another system we built internally, which is sort of an important, increasingly important part of our platform, is a thing called Catalog, which is our own kind of publish-subscribe system, where the core part of the system is a kind of rendezvous point for different applications, a way for someone to say, here's the service that I have, I want to register it, and a way for someone else to sort of look for things that have been thus registered. And I think the importance of this to us underlies the fact that when you're building a great technology infrastructure, it's important to have good abstractions at the bottom, but you need also high-level architectural abstractions that help you organize your overall world. And I guess there's one more, which, for lack of time, I won't mention, a new system we're working on called Nile, which is a new kind of distributed messaging system, which is also kind of an important kind of part of kind of building out parts of our world, in particular our post-trade infrastructure, and kind of managing the complexity there. But maybe I'll save more details about it for another talk. So, very briefly, let's talk about where we feel like we're going from here. As I said, we are fully embedded. We are using functional programming, and we are not changing. We have a couple million lines of code, and a bunch of people who are, trained to use this language and libraries and infrastructure that's really built into it. And we're not changing course. Like, we are very committed and very excited about continuing to use functional programming. One thing we are doing more is more open sourcing and more interaction with the community, and trying to kind of push some of our technology out so that they can help enrich the OCaml community in general, and by the by, help us hire more people over time. Since hiring great people is always an important thing for us. And generally speaking, more collaboration to kind of get out of the community around OCaml and around the functional programming world in general, get more improvements to the core technology. Right? So we have, for example, when we're working with a company called OCaml Pro, which provides commercial services. There's the core team at INRIA. There's a new lab that we're helping set up in Cambridge. And by working with all of these groups, we really want to help drive more innovation and more quality into not just the core OCaml compiler, but all of the tools and all of the language infrastructure and all the community infrastructure around it. Because one of the challenges, the biggest challenge in functional programming, is not a problem with functional programming, it's the problem of being a minority language. And I think that by trying to grow that community, we can really ameliorate that. And from our point of view, it's an important enough part of our kind of strategy of what we do that it's really worth investing in that. So that's kind of all I have to say, and I'm happy to answer questions.